All right, so in this video, I'm going to do questions 4 and 5. And it says, which graph best represents the graph f of x equals to x plus a squared minus, times x minus b. Sorry, something is really funny. I don't want to start this over. Let me continue doing this. Where a and b are positive real numbers. So this question actually could be accessible in a calculator. I'm just going to tell you, hey, choose any numbers for a and b, but it has to be positive. So for a, let's say a equals to 4. Even smaller than that. A equals to 2 and b equals to, b equals to 3. So let's substitute a and b with the values of 2 and 3. For example, f of x equals to x plus 2 squared times x minus 3. Do not change the signs in the polynomial. Just replace the a with 2 and the b with 3. And this is how it should look. So now let's clear the graph. We can go to y equals. Let's clear this. Let's enter this part into our y equals, our y1. So that's going to be x plus 2, close parentheses, squared, times x minus 3. Close parentheses, hit graph. And then you should pick which graph this best represents or resembles. I think I should change my window back from -10 to +10. This one looks like number 1. I mean, similar, yes, similar to number 1. And there you go. The answer for 4 is number 1. So in this case, just choose your values. Choose your values of A, choose your values of B, plug it in, right, and see which graph best resembles the one under examination. And like I said, once again, in this case, graph number 1 for 4. So let's clear this because we're done with that. Let's do number 5. It says the graph of a cubic polynomial function p of x is shown below. If p of x is written in factored form, which is a pair of linear factors, which factor could appear twice? So when it says which factor could appear twice, that means some factor of x minus a is raised to the second power, or some factor of x plus b is raised to the second power. One of those. So let's find the zeros. The zeros in this case appear to be -2 and +3. So the zeros are -2 and 3. So my polynomial f of x is going to equal to x plus 2. Remember, the zeros have the opposite sign from when it is in the factor, times x minus 3. Once again, the zeros have the opposite sign from when it's in the factor. But one of those has to be squared. One of those has to be to the second power. So let's put our second power on x minus 3. So that's x minus 3 squared. And let's graph this polynomial in the y equals. Something similar to that already in there. Now, I know what I kind of did. If you see it, you see it. So let's do x minus 3 to the second power. Let's move the arrow over. Let's square that. And let's graph. Now compare the two graphs. Also, and by the way, by process of elimination, we know x minus 2 cannot be a factor, and x plus 3 is not a factor, because our factors are literally x plus 2 and x minus 3. But when I try it like this graph does not match the graph on the assessment. So that means the factor that appeared twice is not from the x minus 3. That has to come from the x plus 2 factor. So we're going to change the graph, delete, move the arrow over. We're going to square the x plus 2 factor, and we're going to regraph. And if you notice, this graph looks awfully a lot like the one that's graphed on the calculator. Matter of fact, this is the same kind of graph that's in for number 4. So the factor that could appear twice is x plus 2 in this case, because by process of elimination, we found out that it wasn't x plus 3, or x minus 3. So also, I want to say this. When it touches the x-axis, it has an even multiplicity, which means it can appear twice, it can appear 4 times, it can appear 6 times. And when it crosses the x-axis, it has an odd multiplicity. So like 1, 3, 5, 7. So I mean the factors could appear once, twice, 5 times, 7 times. Even multiplicity touches, it could appear twice, 4 times, 6 times, 8 times, so on and so forth. So that's it for number 4 and 5.